Right. Pavel and Nadal, come over here as well, please. So a few logistical problems.
Sorry for
now. Welcome everybody to, actually it's not represented on the slides, to our joint Kubernetes and Docker meetup. And we've got some nice guests, but we'll come to that later. So first of all, I'd like to, I was requested to give a word from our sponsor, because we're not only having drinks today, but hopefully if the pizza gets delivered in 45 minutes, we'll also have pizza. And our sponsor requested us to convey the following message. Next slide. The team Kubernetes at SAP is hiring, right? Like many. So even SAP has a large Kubernetes or cloud native strategy story. And if you're interested, or if you know somebody who would be interested, please contact our one and only Martin Kreischer here, the email, and the slides will be also put up later. And we welcome students, anybody with Linux and container knowledge. That'd be really appreciated. And you'd be asking, what is SAP actually doing with containers and with Kubernetes and with cloud native? Next slide, please. So one of the examples, which you can actually now even look up, is a project we call the Project Gardener. It's our method of creating Kubernetes clusters across various clouds, so Azure, AWS, Google Cloud Platform, even our own data centers, and we'll also put in support for Alibaba and so on. And it's completely open source. You can actually do some pull requests if you have some interesting ideas. It's an API-first kind of design. Multi-cloud I already told you about. And it's our cloud native strategy on which many other projects at SAP and outside of SAP, that means our partners, will be building upon, right? Okay, with that message taken apart, out of the way, some requests to logistics. The drinks you have already discovered, the toilets are over there. Please clean up a little bit after yourself, because this is a private session, so nobody's cleaning up behind us, so I would have to be cleaning up behind you, or my colleagues. And our next meetup, we've decided, because it's difficult to actually get the speakers on real hot topics on premise, that means into Heidelberg. So the next meetup is going to be virtual, and mark your calendar. They're going to be interesting speakers like we have today. And thanks for speakers to have made it to Heidelberg. Yeah. So Christian is actually going to bring us the latest information from Docker, what Docker is up to in the realm of Kubernetes. And well, you can read up.
Sorry.
Oh,
sorry.
Yeah. You can read up about what he's going to talk about later, because he's going to do it just about live. Right?
No.
Give a hand. Yeah. Give a hand to Christian.
Cool. Okay. Thanks.
Stop sharing. Okay.
Present desktop.
Try again.
Present now. Proceed. Pray.
See.
You see my desktop? No.
Let's see. Give it a second. Last time it took a moment or two.
Yeah, maybe I can introduce myself. You see, you have to scare it, and then it will work. Yeah, thanks for the invitation. I mean, I'm happy to give talks anyway. I like to talk, so that's why I'm here, I guess. I brought some swag. I started the week in Zurich, and I had like 4 or 5 touch points where I met with people and talked about it, so that's what's left. I brought a complete suitcase, but now it's only a couple of or t-shirts, but next time I will bring more.
If you're willing to speak, you can get a shirt.
Yeah. I think I even have a Windows and Docker t-shirt, so if you have like weird questions, you get the t-shirt and you have to wear it. I like Windows. Anyhow, yeah, I'm with Docker for 4 years or 4 months. I forgot. I think it's more 4 months now. I'm a technical account manager for the German-speaking region, so for Germany, the DACH region, right? And what I'm doing is being not the devil's advocate, but the customer, the technical advocate. So I advise customers as to how to use best our technology, right? And I also am able to escalate within Docker issues that customers have, or relay feature requests that customers have. And since I have a couple of accounts, I can hopefully get the meta view and subsum or summarize problems that are facing a lot of customers so that we can focus on that. So I'm your friend, basically, if you pay me. But that's, I'm your friend as well if you don't pay me, so that's fine. Yeah, and as said, I work for Docker 4 months, but I used Docker for 4 years. That's where the confusion comes from, I guess. Started with version 0.7 in 2014 or 13, so it's a long time ago. And I started, as everyone, I think, misusing containers as virtual machines. And I like to clean the way today a little bit by providing first the technology. So what are containers and how are they different from virtual machines? And I hope that it's not, for most of you, interesting to see. And I have some slides, I think, that are rather interesting because I try to look at it from different angles. So if you agree that you already know what containers are, then shout and I will skip slides, but hopefully not. After this, I will present how you can move this Linux kernel technologies to be able to use actually Linux containers. So I will describe how a container engine is put together and what pieces are there then. And at the third part, I would like to shed some lights on how a developer workflow might look in the future, because now, since we have Kubernetes support, I would like to see that we make it, and I think we're on a good way, to make it easy for developers to not care about the orchestrator at all. So that you start with your Docker file, but I will talk about it later, so I won't start today. I'll start now. Okay, cool. So as said, if you are bored, because the slides are already known by everyone, then you can shout, but hopefully you won't. So a little bit of container history, and I really like this slide because I stole it. It's from a talk on the KubeCon last month as well. And it describes a brief history of Linux containers, right? So we started with change-root, then Jails brought change-root to the next level, and then we iterated through various steps until we came, I think it's fair to say, to LXC, which was a virtualization technique which used container technology but felt like virtual machines. So you had to set up a device, a block device, you had to set up your network. So it was kind of cool, but it was not really nice to use, or not nice to use. I mean, I haven't used it much, so excuse my judgment. But I had a colleague in my last job, and I worked for PlayStation now, and he was a big fan of LXC because he grew up with LXC, I think. And he tried to convince me that I should go back from Docker to LXC because it's so easy to use. And I was like, what? What are you talking about? And I think it was rather, if you're used to the easiness of Docker, and then I think going back to LXC was not a good choice. So I didn't. But Docker stands on the shoulder of giants. I mean, everyone in open source stands on the shoulder of giants, but I think Docker in particular because we use all these nice technologies, C groups, namespaces, which are part of the kernel, and we just make it so that everyone can use it. I mean, this was the early days of Docker, right? Everyone should use containers, and everyone should be able to do so. And containers are, if you grab containers in the kernel, there's no such thing as containers, right? In the kernel, it's just C groups and namespaces, right? The easy version would be C groups and namespaces. The harder version would be that you also add some security with SEPCOM filters. And this is what you think, or you should think of when you talk about containers. Okay, cool. So this slide, rather nice. First, we should talk about namespaces. So a short recap on that. There are a couple of namespaces, and I have a list in another slide. But the easiest to understand, I think, is the PID namespace. And there's a slight error here, I think. Yeah. Can someone spot what the error on the slide is?
So shell in the container 0.
That's okay. Right. It's not pit 0, it's pit 1. So when you start a normal host, right, then the first process will get the pit 1, and this will most likely be the init system, and the init system will then start all the different processes. And this namespace you can think of as a resource table. And so in general, every Linux system has this kind of resource tables. And if you start a container will get his own resource table for certain resources, and we will talk about this in the next slide. But the easiest thing is it's pit namespace. So a pit is a process ID, and the process ID table tells you that this binary has a process ID whatever, and is a child of this process ID, and you have some information what the kernel knows about the process, and this is used to deal with stacks and all this jazz. So if you are into operating systems, this is what you need to have in order to make sense of all the processes that are running on your host. So the host sees all the pits on his system. So the host every time if you start something within the container, then it will be shown as well on the host namespace, the host pit namespace. But the container will have its own view. And I have a little example here. So if you do this command, then you will have the ps-ef command from within the container thinks it's the pit 1. And if you do something like this, so I start a container with sleep 10, and then I use the same host, the same pit namespace as the host, so this is the second line, to see what the kernel thinks, so the host thinks what process ID the sleep process had. And he thinks it's 9670. But from within the container, you could see that the sleep 10 is given the process ID 1. So it's just a little drug that you put onto the container that he thinks he's the only guy in the room, and he cannot see anyone else. And as I said, there are now 7 namespaces within the kernel 5.10. You get your own mount points, and it's kind of, I think it's intuitive if you think about it, if you want to create a virtual machine or if you want to partition a system into different resources. So you have the mount namespace so that the container has its own userland, its own file systems. You have the process table I already showed. The network namespace obviously provides network resources, so IP table, IPs, and routing tables, app tables, and so on. IPC prevents the use of shared memory. So if you want to talk to another process efficiently, you can use shared memory, right? And if you have this namespace enabled, which you have if you just start a container, then you cannot talk to other processes and other containers. So it's not enough to only separate them by the process ID, because you can somehow get the hint where the process or what process ID you have to talk to in order to make contact. But this namespace will prevent shared memory uses between the processes. Then the UTS namespace, it's a rather strange one. It only provides the host and domain name. It's a Unix time-sharing namespace, so it's an old one. User namespaces allows you to have a root process within the container with the user ID 0, right, root. But from the kernel perspective, it has a different user ID. So you can say, take the offset 10,000 and apply it to a certain container, and then the process ID 0 within the container will be the process ID 10,000 for the kernel. So it's unprivileged, it cannot do certain things, but within the container it thinks it's God. And this is what you want to do. You want to elude the process within the container that he owns the world. And the C group namespace is rather new, and I stumbled upon it, I think, when I prepared the slides, because it's not, I used it, I haven't used it much, but it's also a nice one, because if you, for instance, start a container with systemd, then systemd wants to take care of everything, so it creates a C group for the unit that you created, and this C group will be used to check for metrics or check for resource consumption, and if you want to stop or force the unit to stop, you can then use the C group to rip every process, or freeze the process group. You can also freeze it and restart it. And before this namespace, when you started a container, the Docker engine would create its own C group for a certain container, and with this you can say, okay, I have already created a C group, then you give it the string, and then the Docker engine will reuse the systemd C group for the container and don't create a new one. And so as I said, all these namespaces are part of the kernel, and the kernel uses it to schedule resources and make them know each other and make them communicate to each other. And a host so has its own namespaces. And if you create a container by default, it will get all these namespaces for himself. So we have 3 containers here, and everyone has its own namespace. And this feels like a virtual machine, right? Even though it's not, but it feels like it. But where this thinking of virtual machine breaks, and you can confuse people with this, because it's not really doable in virtual machine or traditional virtualization, you can share namespaces. So I could create a container that reuses the namespace of the host, and I could also create a container that reuses the namespace of another container. And where is this used? Kubernetes. So this you can do in Kubernetes. Every time you create a pod like this, most atomic item or most atomic resource to scale out or to schedule, it will create a very tiny little pause container that does nothing but pause, and this container will create all the namespaces. And if you have a web server that wants to communicate using a network interface, you will create a new container here, like container 2, that shares most of the namespaces of the other container, of the first container that is started. So even if you only have 1 container in your deployment, actually you have 2, without even knowing it. And this is a cool concept because then you can have a login container in the pod that is on localhost, and you can use shared memory to communicate with this container. And another container can then jump in, use localhost, and he can make sure, or he can be assured that this localhost address will be there because the host container will create it. And so you can have different file systems, so different containers doing something for you, doing something in your pod, and they don't have to respect the other's user land. If you think of it in a virtual machine, when you have multiple services, every service can only work with the libraries that the operating system provides, right? And by doing this with containers, as we all know and we all like, you can stretch this out and not use the user land of other containers. Okay, and now it's a rather scary slide now. So if you are easily scared, so maybe you should look away, because what you can do is you can do this, and you can jump in all namespaces of the host, except the C group namespace. So this is a lie. I lied here. And you can also not join the mount namespace. That's why I have to do change root. But what I do here is, I do SSH, root SSH into the host, basically. It feels the same way. So with this, you use the same PID namespace, the same IPC namespace, the same network namespace. You cut off all security options, and with this, you will have a process on the system. And why that's useful, maybe it isn't, because it's rather insecure. But if you're, for instance, on a Mac or Windows and a virtual machine that is very stripped down, so for Docker for Mac we use Alpine, right? And we use LinuxKit to create a very minimalistic image. And this very minimalistic image has no SSH. So if you want to get on top of this machine, you have to do this. And this is why I use it. So you can look at logs for the Docker engine by connecting to this thing. Okay, everyone, no one looked away. So, okay, so this is isolation, right? And namespaces are only isolate. So if you have a container that consumes resources, then namespaces will not constrain this container in any sense. So for this, you need C groups. And C groups, as we saw on the history slides, were created under process groups within Google, and then they donated it to the Linux community, and it was renamed C groups. And what it does, it has a mechanism within the kernel to do scheduling. Yeah, it says Skype for Business quit unexpectedly.
Never happens.
Should I?
Can you try to restart it?
I try to restart.
It was too scary.
I'm scared, yeah.
I have a question.
Yes.
The command you used before, did you use it to get into the container or?
No, into the host. So you're on the host system then. It's like SSHing into the host.
it's typically helpful if you have, for example, Kubernetes for Mac, so that you can use Docker as the host and then log in to see Linux kit logs, because it creates a minimalistic VM, and you can now log in, use Docker for Mac as the host, because it doesn't natively install Docker on Mac itself. It uses its own HyperKit VM that you can log into using this machine. So goes back to the host.
Yeah, it's scary stuff. So if you talk to security people, then they will say,
That will suck.
yeah.
This will not work.
I was a little bit confused because it looked a little bit like the attach command.
Yeah.
Yeah, it kind of is an attach command to the host, even though that, What shall we do?
I
Plug my
sharing.
my laptop. Yeah, it's, or maybe I restart the. Any other questions while we are challenged here? But
So give it another go. If no, we switch the screen.
Yes, we can.
And then if no Skype, then no Skype.
and is it somewhere near, or how do I start it again?
The Skype? That should work the way you just did it, right? Can you try the link from the email? That should open the right session. Trying. Okay, just a second. I need somewhere to press accept.
Almost there.
See. Admit. And now you should see it, and now you should be able to hit the share screen.
You have to make him. You have to make him at present.
It's not by default. Can you try again? See the button. Okay.
Okay, any moment now? Other
Last time it
questions
was
so far? Still connecting?
Connecting?
Yeah.
Yay!
Here we go! Yay! Okay, back in.
Stay there.
Stay there, don't move. Yeah.
Move the mouse.
So again, as I just said, so C groups are able to constrain resources. And this example here has two containers, and I use two kind of C group options here. I can pin a process group, so a container, which is a process group, to a certain CPU core. So I pinned it to both of the containers. I pinned to 0, so the first core, so that my laptop is not melting down. And then I gave the upper one 200 shares for the CPU, and I started a program stress, which is an application stress, which just stresses the CPU. And the second container also is pinned on the first core, but it only has 100 shares. And if you look carefully on the bottom there, you see that first, when only one container is running, you have 100% CPU consumption by this container. And once the second container starts, it balances out to 2/3, 1/3, so 200, 100 shares of the CPU. And this is done by the kernel, so the kernel knows about all the resource consumption of all the processes on his machine, and then he will just throttle one of the containers to not exceed his shares. And when a container is throttled, you can see this in the metrics as well. So CAdvisor, I'm not sure if CAdvisor exposes it, but it will, I guess, someday. So you can see how many cycles a container was constrained. So how many cycles, CPU cycles, a container was throttled, which is a good indicator of oversubscription on the host, right? So keep this in mind and look for the throttled CPU metric. I think that's a good indicator of resource consumption. And there are other C groups as well. So there is network, so you can constrain on network traffic, you can constrain on I/O, you can constrain on bytes or packets or I/O requests to the system. So a lot of resources in the kernel are constrainable, which is pretty nice. So, okay, we have namespaces and C groups. Now we need some nice tool to manage the containers itself and make it easy to use. And this is where layering comes in. But first, I have stacked view. So the layering comes by later. Just a quick, and I think many of you saw this kind of slides already. So if you have some hardware you want to run something on and you want to use traditional virtualization, you have a host kernel, you have the user land, which comprises somehow the operating system, and then you have services of the operating system and the hypervisor that's running on top as a service. And this is the first user type 2 hypervisor. It could be another hypervisor, but let's not get stuck in the detail. And within the guest, since the hypervisor emulates hardware, it will have the same thing. It will have a kernel, it will have the user land, which is then the operating system of the guest, and then it will run some services, or maybe only one service or multiple services on top of this hypervisor. And the problem here is that you have two kernels, and they both think that they are the god of the worlds, and they will make decisions according to what they see as a resource layout, and they will have conflicts. So, for instance, if you have a 2-socket system with, let's say, 12 cores each, if you give 24 cores to one of the guest or to a guest, the kernel of the guest will see one socket with 24 cores. So it will make assumptions upon a false assumption, basically. So it will make decisions that then has to be entangled by the hypervisor and the host kernel to make a good choice. And this is why, and you cannot get around it. And this is why hypervisors always introduce overhead, even though they did some tricks, and I have a little box with some tricks to make it faster, but you cannot get as fast as a host. Whereas, and this you have then virtual machine 1 or virtual machine 2. Whereas with containers, you don't have a second kernel because you don't have a hypervisor that emulates hardware. You just have multiple process groups that are the containers, or instantiated container images, then containers. So you have the user land of the host, which is on the left side, and you have services like on the traditional virtualization side. But you also have multiple process groups with their own user lands that then run on the same host kernel, and the host kernel knows about everything. So you have container 1 and container 2 there. And another view on this, and I think that's a rather interesting view, but I'm biased because I created it. Is this from the application to the kernel, to the hardware. So if you have an application that is statically linked and statically compiled, you have hardware, or you have syscalls directly to the kernel, so that would be this rectangular thing, or you use libraries such as libc to communicate with the kernel and reuse some code that someone else wrote. And then you have a library that is then interacting with the kernel using syscalls. And in the sense of virtual machines, you have this kernel within your virtual machine, and this guy talks to the hypervisor. And in Linux, you have 300 or 400, 350, something like that in the ballpark, syscalls. And Xen, for instance, uses, they call it hypercalls, or with hypervisors, they call it hypercalls, I guess because of the names. They only have 30 or 40, so 35, I think, 40. I think 40 now. And they are especially and exclusively designed to make this virtualization secure, and they are designed to make this resource isolation and make everything secure. So they are designed to be secure, whereas the syscalls, they are created like long time ago in some cases, and they are not all namespaced, and they are not all ready for namespacing, but I mean, time goes by and the syscalls get better and better, but if you can exploit a syscall on a containerized environment, then you are exploited the host of the kernel of the host, and then you are root basically on the host. So that's another view, and I talked about nice shortcuts here, fancy shortcuts. So with this approach, only having this hypervisor, it's rather slow, right? Because every CPU call has to be extracted, and it has to be rolled out, and then the hypervisor has to make some weird stuff to make it then to the actual CPU. And the same goes for network traffic and block device traffic. So over the years, there are a lot of stuff, a lot of shortcuts invented to make this faster. For instance, you could pass through a PCI device directly to one of the guests. For instance, for ISDN, this was a cool thing. so that the host was not seeing the ISDN interface or the fax PCI device, but it was rather given to one of the guests, and then the guests could use it as it would be real hardware, because it was, and other things like drivers and such. So it was sped up. And on the right-hand side, we see containerization or OS virtualization, and it's just like that. So you have an application, and maybe you have some libraries, and they talk directly to the kernel. And that's it. So that's a container. And you have multiple of those, and they are all within their own user land, and they are all free to do whatever they feel right. And the good thing is, I mean, best practice is to have only one process within the container, and by doing so, you can get rid of all the garbage you do not need for this process to work. So if you have like Ubuntu, you don't need systemd, you don't need this, you don't need that, so you can clean up a lot of stuff. Okay, overlaying file system, but I think I can rather rush through it. I mean, everyone knows it, right? To make containerization a cool and usable thing, it's nice to have some way of layering a file system together, like making a cake and piecing them up together so that you can reuse file system layers in other containers. So if you have like an Ubuntu 16 base image and you install the JRE version 9b114, then this will create a new file system layer, this run part, and it will be layered upon the Ubuntu image. And if you want to add a jar to this, then you will create another file system layer with the copy command, and now you have 3 file system layers for this image. And cool thing is, if you have app B as well, then you have 4 file system layers now, but 2 of those are shared between the 2 images, so you don't need to store them again. And if you contrast this with virtual machines, I mean, there's also deduplication and all this, but for a whole virtual machine, you have to dump a virtual machine image and then store it somewhere, and then you have to transfer a lot of data. And here it's rather small. And again, if you have a new GRE version, you can install it in another container. And if you are smart with your Docker files for the application, you can use build arguments to then not even have to change the Docker file of the application, so that you can then, your build tool, Jenkins or what have you, can then pick up the new JRE version and create a new application without someone interfering. Okay, that's container technology, namespaces, C groups, layering. I didn't touch security, but because I'm not a security guy, but I mean, I scared you. Or maybe.
We have a follow-up talk.
Oh, yeah, right.
We continue
Forgot.
with security.
Yeah, that's good. So I did it on purpose, let's say. But how can we use these technologies to make something work? So a little word, and rather it's only 4 slides or so, about the engine architecture. So if you want to use these container technologies that are in the Linux kernel and you want to make it work, you need somehow to bundle it up. And we see here on the bottom, the operating system provides C groups, namespaces, and layer capabilities, and other stuff. And the Docker engine, for instance, as one example of an engine, uses runc and containerd and some other libraries and tools to make it so that you can create a container, start a container. And from the bottom up, the most, the simplest part and the bottom part is runc, which is a command line tool to spawn and run OCI compliant images. OCI compliant images, you ask, that's just a root file system, so a directory, and some JSON to explain to runc what to do with this file system that you presented to it. So it will, if you do runc exec, or is it start, runc some command, and you point it to the config JSON, it will instantiate a container, and then you can do stuff with this container. And it will be an interactive process. To make this reusable to all of the operating system, we introduced containerd, which is just an example of how to put everything together and not only spawn containers, but fetch file systems, fetch Docker images from registries, and create the file system so that runc can start a container. And also it exposes some metrics about the container and some metadata. And the runtime here, we see I have this runc logo here, but it could be Rocket, it could be Cryo, it could be whatever container engine is compliant with OCI. Another ingredients you need is network, because containers are nothing without network. When you start a container, the first thing that the Docker engine will do, it will create a network sandbox, which is not a container, but just a namespace. And this will then be used for the container to spawn into. And libnetwork provides a plugin or pluggable system to connect multiple namespaces with bridges on the host so that you can actually communicate with the outside world, download stuff, or provide services. And this connection to the bridge, just as a side note, limits on one host you can only have 1,000 container connecting to the same bridge, or like 2 to the power of 10 bridge endpoints. So just as a side note, if you have Docker engine running, or it's not a Docker engine thing, it's a kernel thing. The kernel has only 10 bits for bridge connectivity. So just as a side note, if you have 1,000 containers running. Then the storage driver handles the overlaying file system. So if you instantiate a container, what it will do, it will fetch the file system of the host, or of the container image, sorry, and it will make it a read-only file system. And on top of this read-only file system, it will create a thin layer that you can write and read files from and to. So the image layers, they won't go away, so they cannot be changed, but you can just do changes to this little container layer on top. And if you look carefully to what Docker build does, it does exactly this. So every build command instantiates a container, so it says like running in and then the ID, this is the container that started, and then it has -- smaller than. And this one is the commit hash of the Docker commit command that was committed or created or started under the hoods. And then we have a lot of plugins. There are 6 now, and 7th is graph drivers, but I think it's experimental still. So you can extend the function of the engine with plugins. So you can have other values like NetApp or networks like Cisco, so you can extend it. And on the right I have the Go interface, which you need to implement, for instance, for the volume driver. So it intercepts whatever a command is done, and it will then create a POSIX file. It will mount whatever file system you want to mount to it, and it does this like within the command path. And just as a side note, the architecture on Windows looks pretty much the same as on Linux. So they sneaked in the notion of C groups, namespaces, and layering capabilities within Windows, and they created this host compute service which exposes an API for the Docker engine to use. So Linux and Windows are pretty much the same. They have different names, obviously, so it's job objects, not control groups, but the concepts are similar, and now you can run Windows on top of Windows using the same Windows kernel, which is the same concept as I described, but kind of nice. Yeah, haven't seen it much, but I think it's coming.
So I haven't looked at Windows in the past, but if I want to run a Linux container on Windows, I still have to run an Hyper-V environment, right? So
exactly. They introduced an Ubuntu userland, a couple of subsystem, a couple of months ago, last year somewhere.
Q4.
But I don't think it's so complete that you can run all syscalls against it. But maybe it will evolve to having the interface or the ABI that the Linux kernel provides within the Windows kernel, which would be interesting.
Kind of emulation of the system code.
Yeah, I wonder how fast this can run. I mean, but anyhow, no judging. And we took this Docker engine now at the last DockerCon, and we added our orchestration, and I didn't talk about orchestration because maybe next time. And we have Swarm, as you all know, and now we have Kubernetes as well. And if you want to try it out, you download the beta, and you can run it on your Mac and on Windows. Unfortunately, not on Linux, but that might come as well, maybe. Okay, that's that. How I'm in time? I'm fine? Cool. Then I would like to...
Here, so you're good.
Huh?
Until pizza is not here, you're good to go.
Ah, perfect. That's a good marker. And so in my third presentation, I don't want to refresh and recap what everything is, but I want to present some idea I had over the weekend, basically. but I had it all a long time ago, but I put it together. So I would like to, as I discussed, or as I said when I introduced myself, I would like to talk about how we can bridge the gap between developers and operations, right? And what do I mean by that? When you want to develop something, your desire is to have the same environment that production has, right? But that's most likely not an easy thing to do because you cannot abstract the underlying infrastructure easily. I mean, okay, surprise, containers help, but not for everything, because if you have Kafka and Elasticsearch and something rather big, then it's hard to scale it down to a single node instance or to a single service that runs on your laptop, because you still want somehow the complexity, and it also consumes a lot of resources, right? I mean, if you have ever run Kafka and Elasticsearch and maybe something else on your laptop, it's rather hungry. And you cannot break down these dependencies maybe in some cases because they are connected so heavily, and you cannot, as said, scale it down maybe. So containers help, first thing, and what helps in the second part, I think, is if everyone is aware of simple orchestration and creating recomposable stacks, then we might get a little closer to make this a thing. And I try to do this with my own images. Sometimes I fail, but hopefully most times I'm not, so that everyone can reuse it. And I will explain in a bit what I think is the easy ingredients to do so. So it works on my laptop. Everyone knows this phrase, right? And in DevOps, you create something, let's say Python or Go code or whatever, and on your laptop, your artifact is the code that you created. And the environment you use is pretty much interactive. So if you want to use a different IP address in your code, you can just hack it in the code, and then you do whatever you need to do to make it work. Where the pain comes in if you have this code developed and you want to put it in production, you have to bring it to operations. And operations, they don't want the code. They might want to have a package or an image to install on the system, or maybe a complete file system for a server to run, or an AMI or whatever. And this environment should be automated. So you need some service discovery, and you need not to hard code everything, and it needs to be integrated in whatever production environment you have. So it's more dev-rel ops, so release ops. But maybe this phrase won't resonate too much with everyone. But what you need is you need to create an image, or someone needs to create a releasable, deployable image out of the code that you just created. And it depends on your environment, who is doing this, and how complex it is. For instance, I work for PlayStation, and they pride themselves to be a Gentoo shop with a big installation. And whoever used Gentoo before, some hands, someone? Oh, okay. Have you written e-builds yourself? Okay, so you know it's painful, right? And if you are a developer, just started at a company, and you created some cool tool or some new Python code in a day, and then someone tells you, okay, well, now you have to write the e-build. And by the way, you need the start script to write as well. It's bash. And so it's a little bit, it's complicated if a developer has the burden to create these e-builds. So maybe sometimes it's pushed to production or to the operating team or the release engineering team to create these artifacts. But then you have this disconnect that the developer doesn't know about what's going on with his code, and he doesn't know until it leaves his laptop, everything is changing, and he doesn't relate to his thing anymore. And it's even worse because you not only have the packaging, but you have QA and performance tests and regression tests and all this jazz before it goes to production. And developments may be done on a laptop on a workstation, and the rest might be done on a cluster. So it's Jenkins or whatever does all the different pieces together. And what I like to see in the future, and hopefully in the near future, that you can do all these steps until you go to prod. Prod you cannot do on your laptop, right? But you should be able to redo everything that's done until it gets to prod, so that you can reason with you can redo and learn what the QA has found, and redo this test on your local laptop, so that you can improve your code and then see if it would pass the QA test. So that's a dream, right? That's the ideal. And we have this phrase build, ship, and run, where run, I think, is more orchestrate, but that's up to marketing to decide, I think. You build an image, and you build it with a Docker file and a context. Who knows what a context is? I can show you the context. So if I go here in my little example, web, for instance, Yeah. If I do docker build, then we have this little thing here at the top. And this is just summing up everything that's next to the Docker file, so all the files involved, and sending it to the Docker engine to create the image, actually. Because you cannot access your file system, right? If you have a remote engine, for instance, then it won't be able to access your file system to add all the stuff that you stated in your Docker file. So what it does, it just sums it up, and there's an option to even compress it. So you could say, I think it's compress here. So it will compress the build concept before the context before it sends it out. So if you have a remote machine and you think you feel that you have a lot of text files that are big and you need to push it over to the Docker engine, you might want to use this to compress it first. Anyhow, but if you have big files in there, then that's pretty painful. So for instance, if I copy this Docker image as this Docker image for the Docker for Mac, then you will see that now it changes. And it first has to create the context, and then it can send it to the engine to compute. And how you can Docker ignore this type. No typo. No, ignore. It will be 300 kilobytes again. So if you have artifacts that are not necessarily part of the image, you can use Docker ignore to ignore them. Okay, that's side note again. Cool, so Docker file context creates a Docker image, and then you push it either to a remote registry or you don't, depending on your use case. And then you have to orchestrate the image. So, and a lot of images, they have a README that says, okay, run Docker run -t, -d, whatever, to create the image. And then if you have a multi-tier app, then you have 3 of those commands. And I think that's rather misleading. It's not easy to maintain, right? It's correct because you need to create images, but it's not really reusable. And what I tried to do the last 2 years, every time I have a functional Docker image, I try to put a Docker Compose file that is a minimal viable Hello World example of this stack, so that everyone is able to spin it up without bothering. And on Docker Hub, for instance, you have Docker pull and commands to create this image, but if it's, for instance, Grafana doesn't make sense if you don't have a metrics backend to read from, right? Or if it's Kibana and you don't have Elasticsearch running. So just a command to start Grafana or Kibana or whatever frontend doesn't make sense if you don't have the backend to use it. And by creating a Docker Compose that describes the minimal use case, or if you are in a production environment, or if you're working on actual code, this Docker Compose file could have all the necessary information that the developer thinks are necessary for ops to know. And then this can be the way to communicate between dev and ops. And yeah, this image can then either deployed by Docker Compose, can be either deployed by Docker Compose or using Docker Stack Deploy. And this I will show in a minute. So as said, everyone should create a Docker file and everyone should use Docker Compose to make it so that everyone can argue and reason about the meat of the problem. And I have this little example from Docker.conf. So it's a little web app and some API containers and a database in the backend. And I think maybe you noticed that there was like this 5 Lego bricks, and then it said like noun, adjective, or verb. And yeah, this I use to show what I'm about to show. I forked it obviously, but hopefully I will get it back to Docker samples. And I asked the guy already, so I think he's fine. So first you build the image. I use Drone CI, but you could also use something else. Not really important and not really surprising or amazing. So that's pretty easy. And when you wanted to start the development environment, you can use no orchestrator at all by using Docker Compose. So I have this small example with 3 images or three containers. And one of those, the front end will expose port 80 on port 8080. And when using Docker Compose will look at the Docker Compose file and then start containers according to what is in the Compose file. But it won't supervise the container. So if a container dies, it's done. It's gone. Then you have to run Docker Compose again, and then it will check your status or the status of the containers running. So you could build a simple orchestrator by just while looping over this command, and then, ta-da, you have your simplest orchestrator ever. But it's only limited to one host, so not sure if it makes sense. Or you use iNotify if you are advanced, and then you just, if you change it, but anyhow. And if you want to change the environment, so I extended the example a little bit, so I hacked with Java and JavaScript, so I felt a little dirty because I'm not really a JavaScript or Java developer, but it's programming, so it's easy. Well, so I added some lines so that you can have an environment variable that will show up in this little Lego box. So and this is like this in the middle, like this version 0.1, and now it's 0.2. So I just changed some information within the API server just by adding an environment variable. And when we run this command here, then it will restart the words container. So you saw that there are empty bricks first, and then once the container comes up, then the words are supplied. So, and I can use the same simple Docker Compose file to deploy Docker Swarm services. I mean, it's a Kubernetes meetup, but maybe you allow me.
It's also a Docker meetup.
It's also a Docker meetup, so it's fine. It's legal. So this will create first network and then the 3 services. And since the web server is a Go server, it's pretty fast. And as said, the API is a Java container, so it will take some time to start up. But once it's there, then you see we have 5 words delivered, and they all have version 0.1. And if I want to scale it out, I can use this deploy command here to indicate I want 5 replicas. Then I run the stack deploy again, and in this case, I removed it before I created this new stack. Because I changed the Java part again by adding the host name of the container to the information or to the web app. So now we have 5 API servers, and all of the Lego bricks are most likely served by different containers. And we can see
keeps watch on the containers and restarts.
Exactly, yeah.
Right?
So yeah, well, maybe yeah. So Swarm and Kubernetes are all descriptive orchestrators, right? You push a status you have desire to run, and it won't give you back, okay. It will give you back, okay, I will do it. Be calm, carry on, and then it will create the services necessary. So it will run this constant while loop, basically this while compose, Docker Compose up, which is not Docker Compose up anyhow, but it will check constantly if the state that is desired for this to be present is present, and if not, it will create containers or delete containers or remove containers or whatever. So this is what orchestrators do. And they are, yeah, as said, they are descriptive. So we just say, do this and make sure that it's running, and I don't want to hear complaints from our customers. But it won't wait until everything is fine, so you have to trust. And we see here that, and I should take it out and ask the question, but now it's out there. So within Swarm, you use virtual IP addresses, so each container has this IP address /32 so that it can bind to an IP address and serve the web content to any of the clients with the same IP address, so that every container uses the same IP address in order to somehow hide that there are multiple containers in the background running. But you see there are different IP address, different host names with the same IP address. And in the normal example, there's only the IP address, which led to this change because it wasn't sure, or you could not see that there are multiple containers are running. And if you use DNS round robin, it will not use this virtual IP address, but it will use the real IP address of the container, and it will serve it with this IP address. And it will round robin, as the name indicates. And this is rather slow because round robin in DNS has to be updated, and so sometimes it takes a couple of seconds. So that's why VIP is the thing to do. And we can do the same as with Docker Compose up, change the environment variable. Then Docker Stack Deploy will update the status, right? It will say, okay, now I decided to have something else, and then you provide it to either Swarm or Kubernetes, and it will then show or update the service that you changed. And it will do it, you can have multiple parallel containers running. You can tell it, okay, please start the new container first, and once it's ready, then you kill the old container. So you can have multiple strategies here. And after some time, you have all the containers updated. And then you have 5 containers out of 5, but everything's fine. And now with the Docker for Mac and Docker Windows, you can use Kubernetes, single node Kubernetes yourself, so like Minikube, but without Minikube. And it looks quite the same. So I toggle my orchestrator to this environment variable, Docker orchestrator Kubernetes, and then I use the same command, docker stack deploy, to not create Docker services, but use the API server, no, not the API server, what is the service name called? Like controller, API controller, something like that. So a special service which everyone can create themselves, which uses some format and then creates the object you need to create in order to make this work. So we have the same structure in our Docker Compose file, but by deploying it against Kubernetes, it will create the object that you need, like services, deployments, and ingress, and whatever. And that's it. There's no pizza, so I can still talk. And I think that it's for this. I like the idea, but it's my idea, so biased. But what I just showed is that the developer doesn't need to know about what container or what orchestrator to use, right? And he can just have this simple Docker Compose file, or maybe not so simple. So he adds environment variables, he adds mounts, he adds whatever, he adds like the stuff that he wants to see, whatever orchestrator is used, he wants to have in his container. And then operations can decide what else to add. Maybe they say, okay, we need some way of auto discovery that we have to tinker there. But it uses the same source file, the first iteration on the Docker Compose file from the developer. And when they meet, they can just reason about the Docker Compose file and then make it, maybe improve it or debate what's need to be done there. And the diff from the Docker Compose file of dev and the Docker Compose file of ops is what has changed for production, right? And then it's easy to reason about this two steps, development and production. And I mean, this could also be used to, you can download all the manifests for all objects, right, from Kubernetes. So this could also be a way of exchanging just the basic abstraction of the service. So you push it against Kubernetes, then you extract all the objects, and then you have all the manifest files you need. And so it's up to the service that makes this transition to decide what's best, and then it's out of everyone's hands. But yeah, that's an idea. I think it's explorable. Okay, questions? And we lied with multi-nodes, but I mean, I can make this lie go away, but maybe first some questions.
How would I have to set up if I want to use node Kubernetes?
And what Kubernetes cluster you talk about? Like our?
So maybe I ran something on Amazon, and now I want to use Docker Compose and like run against this. Do I have to log in or set up something special?
If we talk about Docker Enterprise Edition, then I can show you. So maybe I have my little Docker cluster here set up on my laptop with Vagrant, and it happens that I know the password and I have a license. And I will come to your question, and it's not like super pitchy here. So I have a cluster with only one node. It's like the manager node. And if you want to deploy something to this cluster, you have to create a client bundle. And this client bundle will have a certificate and the host name, so everything will be set up in order to connect to this cluster. And I didn't try this out, so let's hope. Ooh. Should. Here we go. Where is it? Oh. My hands. Huh? Come on. My laptop's broken. Anyhow, maybe I can. Downloads, UCP. So I source the environment, H, the Docker info, and it's not working. Well, because I have SSH. Okay, I didn't practice again what demo got. Yeah, that's too bad. But normally, if you do Docker info, so now I'm connected to my Docker for Mac engine, right? So I'm connected to the server here on this Linux. And if the certificate would not be fucked up, then I would see that my server will be the UCP server, and then you can deploy, and it will. And this environment it's pretty much self-explanatory, I guess. It will set the Docker environments variables to communicate with it, and yeah, it will use. Yeah, I'm not an SSH or SSL expert, so yeah, I should have tried this out, but I was not aware that this question would come up. But yeah, normally it works. And sorry, I mean I cannot show it, but I guess you believe me that if you do source amp and you have like a certificate that's working, then it will work. And then you can do the same as I did for to my local cluster. And how to extend this, you ask? And it's pretty easy. So if I have a look at background status, I'll type I'm hungry status. I started a new node 0 here, and this I started without provisioning, so I did this no provision command or option. And when I log into this node 0, the other one maybe I log into. So, around page 0. So I have one node, and the other one is not connected to anything. And by going here, export, I can create this Docker swarm join command that I need in order to join the cluster. And by doing so, this guy will have joined as a node. And what we do with our Docker Enterprise Edition in Kubernetes, typing is hard. We will create all the containers in order to make Kubernetes a thing, right? So we look here. Names. Minus format. So there are a couple of containers running. So this is all the Kubernetes part here, all the containers running here. So that's the native, it's a proper upstream Kubernetes. It's no like Docker opinionated version of it. It's from a company called that does Calico Tech something. Forgot the name. But it's not. The implementation is from this company. What the name? Someone knows the name, I guess, right? From Calico, the company behind Calico Tech. Huh? Tigera, yeah, Tigera, exactly. That's it. They helped us. They provided the knowledge about Kubernetes, the bootstrap knowledge, and then we have a couple of UCP containers, but that's it. And on the node that I just joined, we have the same kind of containers coming up. So we have all the UCP containers, so all the worker containers you need, and we also start the kubelet and all the containers you need in order to make Kubernetes a thing. And that's how you create a cluster now, or in our neck of the woods. So you just join to a Swarm cluster. We use mutual GLS and the node identity that is part of Swarm, and to like bootstrap the cluster. And so to just take the elephant out of the room, Swarm is not going away because we need Swarm in order to beef up this cluster, or to keep it, to make it think, make it work. So it's basically Kubernetes on top or next to Swarm, and the slide says next to, but we use some of Swarm capabilities, and we need like Swarm services to make this containers work. So kind of next to and a little bit above Swarm.
But
some kind of overhead? I mean, you have Docker and Swarm in between and Kubernetes, so.
No, I mean, they just talk to the same Docker engine, right? So we have here shared resources, which are all containers running, and the nodes that are shared. And if Kubernetes schedules containers, then it just talks to Docker API of the host and schedules containers. So it's not, I mean, it's an overhead of all the Kubernetes and Swarm containers that are running on the host, but I mean, that's unique anyhow. So you will have more containers on the host because you have this UCP, Swarm, and Kubernetes environment. But other than that, there's no real overhead, I think. And here you have like the specifics for Kubernetes and the specifics for Swarm, and you can use them both on the same cluster. And best practice is to have dedicated workers for Swarm and Kubernetes, because for now, but we're obviously working on it because it's an obvious thing to do. If you reserve resources like memory in Swarm and in Kubernetes, they don't know about each other. So if you have a 4 GB node and you schedule a Swarm service which consumes 2 or reserves 2 GB, and you schedule Kubernetes which wants to have 3 GB, they might be put on the same node, and then the out-of-memory killer will go along and reap, and the orchestrator will go, well, I don't know why, because he doesn't know about the other orchestrator reservation. Yeah. But everything else, the images, obviously, if you download an image in Swarm, then it is, because it's Docker engine specific or runtime specific, it will be usable by the other orchestrator as well. Yeah, that's it. And I think, Swarm is so easy to reason about, so that I think it has some legway to schedule simple services if you don't want to get into the weeds of Kubernetes for maybe as a starter. But you can then, if Swarm is not enough for your use case because you need auto scaling or whatever, then you can just switch on Kubernetes, and then all the kubelets and will magically appear, and then you can just use Kubernetes as well. So I think it's nice to have both. Best of both worlds, maybe. Okay, questions?
Yeah. When you use the Docker Compose file on Kubernetes, are you able to specify some Kubernetes-only configuration that makes no sense for Docker Swarm?
Yeah. It's like Docker Compose and services, right? If you have deploy, for instance, in your Compose file, and you do Docker Compose up, it will complain, I don't know what this is, so I will ignore it. And the same will be true for Compose, Kubernetes-specific stuff in the Compose file that is not usable by Swarm, maybe auto-scaling, for instance.
Yeah, like an English configuration for an English controller.
Yeah. This will be. I don't have the spec with me, and I don't know all the specs that you can put in there already. But it will have Kubernetes-specific configuration that is ignored by.
I should expect basically a new version of the Docker Compose format that brings in what's missing to be able to buy both stuff or something like that.
Yeah. I don't know the roadmap, or I don't have it in my top of my head, but that's how it will.
There are some stuff that right now, if I wanted to use the Kubernetes format of Docker Compose, I would not know where to put.
Yeah, but this will be, it will be hard. So
but it breaks your workflow idea from developer. If you still need certain things in the production, I understand where you're coming from.
Yeah, but the question is, and it's obviously something to debate about, but I think that some stuff that like auto scaling, maybe that's totally an ops thing and not a developer thing, right? There are maybe some overlaps where both have to agree on something, but for some things that's totally only related to ops. So auto scaling, I think that's not something that the developer should say, I want this auto scaling to be on CPUs when they have 20%. So that's something totally left to ops. But there are other things that maybe not, like what kind of
idea which comes to mind is like maybe you have some kind of a function as a service layer in your production environment, right? And you want to develop with that on your local laptop, but you don't have a Docker Compose for usage, right? In a Kubernetes cluster, you will have that, and you can combine both elements. See what?
Yeah, you have to do either you have a very big Compose file that has like a lot of additional services that you need. I mean, that would be my model, right? Having having a compose file that has every necessary stacks you need in order to run your app in a very minimalistic way. So maybe you use OpenFast or whatever to create this environment. Or I guess there are already.
I don't want to be a party pooper, but I think this whole notion has been developed for customers of Docker who have invested in Swarm and now need to move. You
mean what I talked about, or Kube?
No, the Swarm compose into Docker, the compatibility mode. Right?
Yeah.
I mean, if you're invested into Kubernetes, you use Kubernetes stuff.
No, right? Yeah, sure. So, if all your developers are already Kubernetes, then, and I didn't show this, but you can use kubectl, you can use the Kubernetes API, you don't need to touch any Docker things. You just spin it up, or you don't, by this, and you can use your normal Kubernetes environment or your Kubernetes tools to run again. I'm just saying that because I don't think that if you are a new developer, you will start directly with creating kube manifests, right? And maybe you want to start simple, and I think that's a simple way to start. I mean, biased because I work for Docker, obviously, but
we can change that.
Careful, I record. But yeah, sure. I mean, it's biased, and that's what I did for the last 2 years. So I have 300 images on GitHub, and hopefully most of them have a Docker file and then the minimalistic Hello World Docker Compose file. And this was even before I worked for Docker, so it's almost also biased because I'm a fanboy. But yeah.
I think the main problem with Kubernetes is the manifest files, right? So people writing Docker Compose, they come from the background, oh, it's very simple and so on. They move to Kubernetes and then they have this huge amount. So I think this is the use case for Docker Compose. For people who already know Kubernetes, just use kubectl, which is already installed with the compatible version with Docker. So why use the Docker Compose in the first place?
No, I think that's like not going back from manifest to compose. That would be stupid because you already know it. It's just a good start, and then you can iterate. And if you're a heavy developer and Docker Compose does not fit it, because we need to create this transformation layer, right? And it won't have the full-fledged functionality that Kubernetes provides, and maybe it won't have it in, it won't be like full-featured anyway. I don't know. I'm not sure what the plans are there, but you can imagine that some specific things are just not added because maybe it's no use case for our customers or for the community. So we would say, okay, we don't need it. Because the theme is that we want to make it easy for developers, right? I mean, Swarm was developer focused, not ops focused, and Kubernetes is ops focused and maybe not so much developer focused, like to begin with. But it's also like it started more in the ops world, and now we're coming all close together. Yeah. So I'm not, and this is the idea for Friday, so it's like a week old, so it's not official Docker policy. It's just an idea. Cool.
So in the meantime, the pizza arrived, so I don't want to be between that.
Thank you so much for the.